All right. I thought as I've been grading the pre-lab one, which I should have done 2 weeks ago probably, or a week ago, um, uh, I've noticed that the last three problems are causing people issues. For the most part, most of you are getting through it pretty darn good. And remember, you can make the corrections and turn it in again if you want. That's fine. And also on your first score, when you get your first score, don't worry about that. Like one of your classmates turned it in and she had like a 26, and she's like, that's because I got to go through and grade it. And the nice thing is, I forgot to delete problem 19, which is a freebie. Just everybody gets problem 19 correct, so don't worry about it. And that was like a freebie. But the last three questions are causing people some heartache. So what I wanted to do was make a quick little video YouTube here where you can see me do the problems. Okay, all right, so let's go on down here to here's problem 19. It's a freebie for everybody. Okay, all right, and then let's get down here to this one too, problem 24. That's causing people some issues here. Choose all that apply. Okay, this was worded not very well. I probably should have added here at a constant speed. Okay, you're probably thinking, oh, you went from 0 to 75 miles per hour. Well, that's an acceleration. No, you're going at a constant speed here. So it's these first three. Okay, so those of you who want to go back in and try, I'm wondering if you can go back in, if I have to grade it first, then you can go back in and then I regrade it or something. I don't know how all this Canvas crap works, but anyway, name 3 accelerators in your car. Most people are doing that really well. And here was another one. Everyone gets 27 correct too, because it's a little high at what there, Professor? What temperature? So any number will do here. I meant first of all, the student would be terrified if she said, oh, your temperature is at 100 degrees. What is her temperature in Celsius? It'd be around 40 or 41. That's what I was after. But everyone gets 27 correct too. Okay, so there's 3 points right off the bat. Boom. And that's the other thing too, is your scores are going to be low when you first turn them in, because I've got to go back and answer and grade these real quick. Okay, and this was a trend I was noticing. The last one, I was a bonehead here. 2 professor mistakes. I left 19 open, and 27 has no number in it for you to get started, so don't worry about it. And then true or false, an object with a constant, oh, this is a fun one. This is a fun one. Can never stop and remain at rest. Here's the idea. I told one of your classmates this one. If you throw a baseball straight up in the air, okay, so I'm throwing can you talk? Yes, I can. You're throwing a baseball straight up in the air, and the acceleration due to gravity is always going to be acting on it. It's not like you throw it up in the air and it hangs up there because there's no gravity. No, gravity's acting on it. That's what's slowing it down. And then when it comes back down, that's what's speeding it up. So that's an object with constant non-zero acceleration. In this case, gravity's at -9.8, can never stop and remain at rest. If something's accelerating, it's moving. Okay, if there's an acceleration on it, it is moving. All right. Oh, and the thing on the force too, on gravity is a force. Gravity is not acceleration is not a force, or gravity is not a force. Gravity is a field. All right, gravity is a field. All right, probably should have done all that. I think I did all this though. All right, so here we go. Let's do 3 problems. And okay, so a basketball is dropped from a tall building and hits the ground in 2.5 seconds. How tall was the building? This is where we're going to get your equation that you're going to need for your little lab. That hopefully you're done. I've noticed quite a few of you got those turned in already too, so that's a good thing. And anyway, I got to turn off my phone. Sorry. All right. So let's take a look at this one real quick. So we've got a basketball is dropped from a tall building. What's its speed after so many seconds? All right, after 2.5 seconds. And it hits the ground after 2.5 seconds. How tall was the building? All right, well, let's take a look at this. Okay. Did I bring something down here to write with? Yes, I hope this will work. Okay, so this is what? Problem what? 29. All right, so this is problem 29. A ball is dropped, goes a certain height, y, and the time is equal to 2.5 seconds. Okay, so we have to figure out how tall is the building? Well, we know this. We know that y is equal to the initial velocity times y times t plus 2a t squared. 1/2 at squared. Where that's the acceleration. All right. Now, gravity is negative, and I should probably put a minus sign here, but I'm just going to make it positive because I just want the magnitude of the height of the building. All right, so if it was dropped, that means the initial velocity is 0. So y is equal to 1/2 at squared. So all we got to do is solve for t, multiply both sides by 2. Oh, we know what t is. I forgot about that. Here you go. All you got to do is plug this guy in. So y is equal to 0.5 times 9.8 times 2.5 squared. And that will tell you, or 2.5 times 2.5, that'll tell you how tall the building is. All right? Okay. So I'm going to stop here and then make one more for the next two for problems 30 and 31.